right? So there's quite a few different challenges. With NVIDIA, what you can do is, we try and build systems and frameworks that you can use off the top of the head, right? Whether you're building with PyTorch, whether you're running your own fast API or SG-Lang inference ecosystem, we try and help you add value to those tools. Okay, I'll show you this later on, but one of the tools that you should be taking a look at is at build.nvidia.com. And I'll show you a demo later. And what we do is we craft a lot of reference blueprints. Think of these as reference architectures for these different use cases. And we constantly keep releasing new ones. And in there, what you can get is a one-on-one bare bone system that you can customize that shows you how to get started with building an AI use case. And of course, agentic AI is one type of use case. You should feel free to explore that to see if there are any others that strike your fancy. All right. Now, if you've been working with LangChain and LangGraph, you've probably looked at Phoenix for your observability. Some of these challenges are not new to you. What we did is, and NVIDIA writes a lot of SDKs, almost all of them are open source. The Agent IQ toolkit is something that we developed and released to help agentic AI developers do three things. One is to profile and optimize the code that their agents write. The second is to help you understand and evaluate the performance of your agentic AI systems. And the third thing is to sit as a central repository so that your agents can share tools across each other's. So there's a bit of a registry. There are some modules that the agents write that perhaps the next time an agentic system is asked to build a workflow, it can just reuse that tool. This helps with unifying the code base. Okay. So if you think of the agentic AI development lifecycle, you'll often see that the agents work in this fashion, where they'll build a plan, they will analyze the plan, they will design a flow, and then you will test it. You will test it to see whether it does what it says, whether the performance is ideal, and then of course you've got to do some integration testing, you've got to deploy it, and then you've got to maintain it. So with IQ, what we try and do is we help you with the implementation and testing, the deployment and monitoring, as well as agent interconnect. The way to think of this is that whether you're using LangChain or LangGraph or your favorite RAG or your favorite Hugging Face checkpoint, this helps you stitch all of that together. Okay, so we'll just move on to some of the benefits for this. Remember that NVIDIA writes a lot of the world's software, and we often customize and create optimizations for you. So when you're using these tools, we generally tend to optimize for performance and throughput. Okay, right. So this is an example of an IQ blueprint. In this one here, we're trying to use a system that is a reasoning blueprint that looks at some data, tries to answer your question, and creates a report. And as you can see, the first thing that should strike you is that there's different LLMs that are being used for different types of the task pipeline. Okay, so a lot of organizations or first-time developers to generative AI fall into the trap of trying to get just one LLM to do everything. So if you're using Llama 3 or C-Line 4, just use it for everything, right? What you should think of is whether you want to customize the different LLMs for different parts. You can use the same LLM. The C-Line LLM is a pretty multi-purpose LLM. You can use it, but don't ignore that you may want to optimize that specific checkpoint at different points in time. Okay. Here's an example of what we use to build a deep research blueprint. So in this, the user asks, do some research on this topic. The agent takes that task and creates a workflow and then creates a report on how you want to do this. As you can see, this is the difference between just chaining together multiple LLMs with a human design versus asking the agent to create the entire workflow. And that's really important distinction and why it's so powerful. Okay, so as you can see, the first thing it'll do is it'll create the document collections, it will create some query tasks, it will create some edit and approve of some of these and say, are these queries worth running for the prompt that it was given? If not, remove those. It'll then do a bit of RAG search, check for relevancy. If it fails, it will then go into the web and say whether it can supplement the information that the RAG system returned with something else. It will summarize and report. It will then reflect on the first version of the report. If it found gaps, it will go back to the RAG searches. This is where the iteration comes in. At every stage, we try and build some duplication. Once it's happy, it'll then generate a summary. It might append the sources to the section. It'll review the source report. And of course, at the end, it could even modify the internal first prompt. You could link it to this. Okay, so let's see how this looks like in action. So here, you're just saying begin research. That's literally all you're asking it to do. And then it says, okay, I need you to give me a report topic. I also need you to give me a little bit of information on how you want the report to be submitted. And here, we're saying just write a brief. And then it says, okay, which kind of sources would you like? Then looks at that, we select the sources, it then goes ahead. And as you can see, it's exposing how it's thinking through. It's exposing what steps it's taken, right? And then once it gives you the plan, as a human, you can approve it. You can say, no, go back and reflect again, and you click submit. And you can see how the agent is really going and describing its thinking workflow. It's gathering data. It gives you an estimate on how much time it takes, and so on and so forth. And at the end of it, this is the final report that the agentic system returned for you. So it's pretty incredible that you can literally get something as complex as this with LLMs today. So that's the difference of the power between using just a set of LLMs versus going and building an agentic system. Okay, so that was what the art of the possible looks like, right? How do you actually go ahead and build this? With IQ, what you're seeing here is you're giving it the tools. You're saying, so I'm going to see if I can build, there we get my laser pointer here. Okay, so if we look at the left-hand side here, here you're defining all the different tools that you'd like this agent to have access to. You're saying, I want to index RAG, and you can tell it what the actual NIM is, and I'll get to that. Well, just for brevity, for now, a NIM is a accelerated LLM inference container. Okay, that is exposed as a fast API. So just think of it, replace your LLM name with your whatever API you're calling or whatever model you're serving out. Okay, then the different LLMs that you'd like, you could even put in a bit of hyperparameter, for example, temperature of 0, says just be creative at all, right? Make sure that your creativity is really stop low versus the reasoning LLM. Perhaps you do want it to have a bit more, you do want it to have a larger input and output token window, for example, right? And then you can define the workflow and say, firstly, call the reasoning agent and the R1 model, and then have the React agent as well, right? So it's pretty easy to set this thing up. And I'm going to share these slides with you. These are other reference architectures you can see that show you how to build different types of agentic systems. Okay, so let's look at that again. I just showed you a product lifecycle management agent. Let's see what that looks like when you see it in action, right? So here you're saying, this is some feedback investigator chatbot, ask me about customer feedback. So then you'd say, well, what do you recommend after having seen this? So it says, okay, well, actually, these are the top 5 or 6 things that you should be looking at, whether it's hybrid-sizing guides, AI agents, or how to generate reports from PDF. So, okay, we say we want to do AI agents for MRs. Okay, let's review. It's then going and analyzing all the customer tickets that it has that relate to this particular topic. Okay, and it's saying, okay, I see that there are a few different questions. It then comes up with some brainstorming questions and a recommendation. It says, based on these findings, I think you should go and do so and so and so and so. Okay, so you can then say, we actually had the brainstorming session. Let's upload the meeting recording, right? As well as some diagrams that we came up with. Take this on and tell me what it is that you like us to do, right? So, okay, The agent takes this data in and says, here's the feature requirements document after ingesting this information. Okay, it says I've provided details on depth, clarity, and style, right? And here we go, you're ready to go. So at the end of it, you've now got a system, it's like a collaborator with you, right? As you can see, there's still a lot of human in the loop activity with agentic AI systems, but what it's able to do is to really come up with deep work as a function. So it's an accelerator for the kind of work you do. Okay, so then you say, great, now create Jira tickets for this feature requirements document. This is okay, here you go. I think there's 48 issues. I've created the tickets, and who do you want me to assign them to? You could do that as well. Okay, so that's how we went from what should we do to improve the product to let's have a meeting and let's run the meeting in this fashion to here's a meeting recording. Now you've got a AI workflow that assigns and creates the tickets for you, right? That's pretty incredible, right? And here you go. You say, which developers are best suited to complete the 3 unassigned issues? This is okay. So it's going to go back and look at all the developers and the kind of PRs that they've submitted, the issues that have been resolved. And this is okay. Based on the historical performance and the historical record, he's worked on several UI tasks, Eric. So let's give him the UI stuff. So as you can see, it's a real good brainstorming ally, and it helps you create all this. And that's the future of work that we start seeing now, right? This is how enterprises, organizations are really leveraging agentic AI within their companies. Okay. So let's now get into a little bit more a bit more technical in terms of some of the performance optimizations. Remember, I said we're talking about really improving the performance optimization with Agent Toolkit. Okay, this is an example blueprint of something that we use to do test-driven development, right? Where we look at issues and we say create tests for it, and then create the code for these tests. Morpheus is one of our cybersecurity SDKs, so that's what that refers to. So here what we said is triage the software for vulnerabilities and exposures, present a summary of findings, and try and help us understand which to go. Now, when the agents create these workflows, oftentimes it's not the most efficient, even despite trying. So with Toolkit, when a workflow plan is presented, it actually does a bit of a deep dive in there, and it does some code profiling. Right? And then it says, hold on, it seems like the agentic triage step is taking the longest at 82 seconds. Most of the latency appears to be coming from a sequential execution. So instead of actually trying to run them in parallel, it said, I'm going to wait for this to finish, and then this, and this, and this, and this. Right? It did that. So basically, it analyzed that, came up with recommendations, and you can use it to help you optimize the pre-built code that your agents are writing for their code execution plans. Okay. It also looks at pretty fine-grained telemetry for your workflow behavior. So what you're looking here at is a histogram of all the tool calls that the workflow that the agent has designed is. As you can see, the code, the call to retrieve the source code was used the most as it attempted to confirm the presence of the vulnerabilities. So this is an example of where you could just maybe cache some of that information, right? Instead of having to call it from source. Or that tells you that perhaps as part of the workflow, have a central dictionary that chronicles the most commonly used code bases, or however you want to see. Go ahead and do this. Okay. The other set of tools that you'll often find is every single one of our SDKs will often have an examples or a notebooks folder in them. This is a really good place for you to go in and see how NVIDIA and some of our partners write code for these problems. Okay. Yeah, so really the best way to think of NVIDIA is that we run a lot of software for AI developers, okay, of all kinds of maturity, whether you're just starting out to obviously, companies like Microsoft or Google or Hugging Face or LangChain. Okay, right. Now let's talk about the fact that, I spoke a little bit earlier about the common trap that developers run into and they'll often try and get a single LLM and try to get it to do everything under the sun, right? And even if you do that, you can pick and choose a single model, but it's also important to try that maybe you want to have different instances of that model optimized to a certain extent. So you find a bottleneck and say, where is it really failing? And maybe I'll optimize a separate version of that checkpoint for this specific task. There is still room for that. Okay. So when developers run into these kind of issues, they really want to rapidly integrate the latest AI building blocks. So for here example, in the planning stage, this developer said we're using the Llama 3.1 400B model to start with, but perhaps during testing they uncovered that actually we didn't really like it or we wanted to optimize, and instead maybe I want to try a DeepSeek model, right? When you are building systems like this, what I often find is that unless you have like a managed service or a direct API call, it can be quite complex to do all these different stages where you've got to implement the API, you've got to build optimized engines. So some of you using SGLang or VLLM or TensorRT LLM, right? You've got to do QA testing. So with NIMs, we try and really streamline that for you. Okay, so what is a NIM? A NIM is a Docker container that contains a highly optimized version of your favorite LLMs that when you just run that container, it will basically spin up a OpenAI fast API compliant API from which you can call the model. Right? So for a lot of the client code base, for example, if you've been using directly OpenAI and now you want to try for some of your examples a custom LLM, or perhaps you want to try a C-line, then you could just basically run the C-line NIM and you'd have an OpenAI API sitting somewhere in some environment. Okay, so that's what a NIM is. Okay, and we've been building NIMs for pretty much every single LLM you can think of. We do it with Gemma 3, we do it for DeepSeek, we do it for Cosmos, Whisper, Chuan from Alibaba, and of course, C-line as well. Okay, so let's go a little bit into what the architecture of it looks like. Under the hood, this is what it is, right? So essentially at the top, it's an OpenAI compatible API that is exposed via Fast API. And inside that, these are all the different parameters that you have. It's not exhaustive, there's quite a few more, but these are the most commonly used ones. Sitting under that, you've actually got the optimized LLM executor. And the NVIDIA NIM will include variants of it. So VLLM, which I'm sure many of you know, SGLang, and NVIDIA's own TensorRT LLM, right? So you'll often find that the larger the model size, or if you're doing multi-node orchestration, then the TensorRT LLM really tends to shine when you're doing that kind of place. And it keeps par with the other pieces, okay? And of course, we run a lot of code with and for, with the VLLM and the SGLang team. Okay. I'm going to skip this chat. What I'm trying to show here is that when you're building NIMs, and for example, if you're using LoRa on top of a C-line checkpoint or a Llama 3 checkpoint, then this is the kind of workflow where you would store the adapter as well with your NIM checkpoint. So it's pretty seamless when you deploy a NIM with that kind of customization, an SFT, a bit of PEFT, or even LoRa. Okay. We also have, if you have a locally built engine, right? This is how you would basically replace the custom weights, the inbuilt NIM weights with your custom weights. Okay, pretty easy, pretty seamless. And again, I'll share these slides via the team after this call, so that you don't have to. I mean, you're free to take screenshots, but I'll share these slides with you later on. Okay. The advantage, of course, is that from a deployment perspective, your deployment single command remains the same. All you're doing is internally you're modifying the NIM to be able to cater to some of these customizations you would have made for your specific domain or use case. All right. Okay. So that brings me to the end of the slides part of the talk. I'm gonna switch my screen and show you something that we use extensively at NVIDIA, and a lot of our developers do so as well. All right. Can you see my window? Okay, what you're looking at here is build.nvidia.com, all right? If you go to builder.nvidia.com and if you sign up, now I'm signed in with my account. If you sign up with your professional ID, whether it's a university email, essentially anything that isn't a Gmail or an Outlook, then what will happen is you will get access to about, I think, a few thousand credits. Each credit corresponds to one API call for all of these different things that we have. Okay, so if you look here, you'll see things like models, which are all the different LLMs that we have names for. What I really want to draw your attention to is blueprints. Okay, blueprints are reference applications for a variety of different use cases and stacks that you want. All right. So remember, we saw the structured report generation, we saw the document research for blog creation. Right? In fact, we've written some of these blueprints with our partners like Llama Index. I'd recommend picking one of these that is aligned with the use case that you're looking to build for this hackathon, and let's go into it. Right? So let's say I want to build a, pick one. Why don't I build a, okay, structured report generation with LangChain. Okay, if I do that, right, you'll be met with this screen. Okay, and if you go down and see, it's going to give you a lot of detail, drawing your attention to two things. Let's click on the architecture diagram. Now, if you click on the architecture diagram, this is the overall reference architecture for how this blueprint works. Okay, as you can see, it tells you where we're using the NIMs, and how you might be able to work with different rack systems, right? So this one doesn't have a rack part for it specifically, but others do, okay? The other thing as well is you have a set of related blueprints. And if you look on top here, you go to options, let's click on the view GitHub. And if you do that, it'll take you to the actual open source GitHub repository that contains everything you need to deploy this blueprint on wherever you want. Okay. So if it's loading, hold on, it's not responding. Okay, let's. Okay. I'm going to go back, build.nvidia.com, and let's look at another blueprint. Okay. This is one that's one of my favorites, the multi-LLM NIM. Okay. Remember, I've been saying this over and over again. Think about how you want to use different LLMs for different parts of your task. One of the common feedback I often get from developers, Deb, I don't know if I want to use a 70. 70B is amazing when it works, but it's too expensive for me to run all the time. And then I say, hey, have you thought about using a 7B model and a 14B and a 27B and do a route, right? So with this here, what we show you is how to build something like that. Okay, so let's go to the architecture diagram, and this shows you, it's very simple. You basically can pick and choose how you want to run your LLM with different sets of LLMs. Okay, let me see if there is also a. There is also the LLM router blueprint here. Okay, let's see if this one's better. Okay, this shows you how, if you have a repository of different LLMs and a router, how for different task types you want to deploy a different LLM for that. As you can see, you've got a Llama 3.8B and a 70B and a 400B NIM, right? So, and you can see, we're just saying these are the different kinds of tasks that we think these LLMs are really going to excel at, right? And then with your model repository, you can pick and choose which LLM you want to serve what kind of task with. Okay, very powerful. And the one advice that I tend to give organizations that are looking to build GenAI and agentic systems. Okay, and again, all the code is open source, so you can go here and it'll tell you exactly how to go from the beginning, all the way from installments to deploying it at your. Okay. Right. Let's see. This is the agent toolkit GitHub that we spoke about earlier on. It shows you how to build. And as I said, um, there's a hello world for sure. That's not super useful once you get started. So once you go in here, right, go to the examples directory, and you'll find almost every single NVIDIA SDK. GitHub has this, and within that, you'll see quite a few different ways that you want to deploy. And if you just want to try stuff out, just go to the notebooks directory within that, and that also has a couple of different notebooks that can help you getting started with building your own custom agents or using agent AI toolkit. Right? So, for example, if you're working with different frameworks, then let's look at this multi-frameworks. This one, for example, shows you how to integrate LangChain and LangGraph agents together with Agent IQ and Haystack and Llama Index and all of that, right? So in this one here, you're combining Haystack with LangChain and Llama Index to build your end-to-end. Okay, and this is essentially what the architecture looks like. Play around with it and do let us know if you face any issues. All right, as you speak to your mentors over the course of this build. Okay, the other website I would highly recommend you to take a look at is the NVIDIA Generative AI Examples GitHub repo. This again has quite a few different generative AI examples for whether you want to create a data flywheel, agentic AI, RAG, as well as just a simple how to get started. Okay, very useful. A lot of our developers have used these to just get started with their build journeys. Okay, at the at the best you can use some of it. At the worst, it gives you some reference architectural ideas on how to go about orchestrating your solution, your hackathons. Okay, all right. The last thing I wanted to talk about before we kind of do Q&A is the deep learning courses that you can take from it. We've got something called the Deep Learning Institute. It's a pretty neat thing. Essentially, it's NVIDIA's training catalog, if you will. And within this, you've got quite a few. There's two in particular that I always recommend. One of them is this thing here called Optimizing Machine Learned Codes with N-Site Profiling Tools. Now, this thing here, it teaches you how to attach an N-Site. Every system that has an NVIDIA card in it will have a profiler with it. Common refrain I get from developers, first-time developers, is, Deb, I only get an out-of-memory, CUDA out-of-memory error. How do I go deeper? Well, this course will kind of teach you how to attach kernel, a running kernel with Nsight, so you can get much deeper messages. If you're a PyTorch expert, then PyTorch also has documentation that shows you how to attach an Nsight profiler to it. Okay. The other thing I'd recommend is in the generative AI piece here, how to augment LLMs with RAG and how to build RAG agents for LLM. Okay, these two are pretty good courses that you can take for free. If any of you are part of a startup, and that startup is a member of the NVIDIA Inception program, then all of these courses are generally available to you for free. What else can I point you to? Oh yeah, okay. You should also take a look at the NVIDIA On Demand website. If you go here, what you'll find is that almost every time we run a developer conference or we have deep tech sessions, then we basically put it up here for a while. Okay, so for example, here we have how to build agentic AI systems with Carrie. I think this is Carrie. So that will help you. Some of these sessions can be very deep, very technical that we run our events. So feel free to go here if you need a bit more detail sometimes on some of these various topics. Okay, I think I've got a few of my videos also. Right, so that brings me to the end of the part where I speak. So I'm gonna stop sharing and if we have any questions, I'm happy to take them. I know we can be shy, so it can be about anything, right? So, well, within reason. Do let me know, and I'm happy to see if I can shed light. All right. It seems like we're a very shy audience today, so no worries. I think we can take 10 minutes back. If you do think of any questions later on, perhaps you can send them across in the chat here. I think we'll be collecting them. Then you can, I'll see if I can answer them. Over to
Thanks
you.
for that. Can I just maybe before I go to my recap, can I just ask if you have any like last words for the participants who are here physically? I mean like virtually, technically, or also those who are watching the recording? Yeah.
Yeah, so I think there's two pieces of advice, right? One of them is specifically for the hackathon. Um, when you are building solutions, the biggest trap I often find um, teams that build these solutions is they run out of time, or they get stuck and they have to really re-architect midway. So my suggestion for hackathon specifically is to build a testing and evaluation framework as you go ahead and build, right? And be very clear what you want to showcase. How do you want to um, demonstrate the quality of your solution? If you think from that, then a subcategory is what is actually demonstratable, right? So once you have that in your thinking approach, then that helps you craft a more reasonable solution. Okay. Second thing, advice in general when building with agentic systems and LLMs is, um, you know, we have known this for a while in machine learning, but it seems to have fallen out of fashion. But fundamentally, these are still computer algorithms. So garbage in, garbage out. So as you build out the systems, as you start building and customizing your models, make sure to give it the right kind of data. Here's an example of what that looks like when you fail. There's an enterprise that wanted to build a custom chatbot for their knowledge systems internally, and they thought it would be a fantastic idea to take all the Slack chat logs for public channels and use that to train the model, tune the model. So now the model understands their company culture and so on and so forth. Right, so this took about 2 to 3 weeks. Very excited. And after that, when they opened up the chatbot and they asked it a question, they said, "Hey, can you help me with so and so task?" And the chatbot responded saying, "Sorry, I'm on leave. Cannot." Right. So, so that's what bad data going into a really powerful model looks like. So don't underestimate the impact of that. Okay, we have one question here, right? Is there licensing restrictions on the usage of NVIDIA APIs? It depends. So we're not a SaaS company or platform. When you go to build on NVIDIA.com, your credits, which we give to you for free, you can use them to try the system out. You can use them for POCs, but once you run out of credits, that's it. Right? So we're not a SaaS platform. The model we're thinking of here is you build with a NIM and you deploy it in your infrastructure in your favorite cloud or your favorite provider like your Bedrock or SageMaker or Vertex or AI, and they'll often have a NIM in the backend. So if you're deploying it to a production system, then I think you probably need to abide by any commercial restrictions. If you're using the SDKs, those are all open source with no restrictions for the licensing. Okay.
Yeah. Thank you so much for your answer and also for your sharing today. Yeah, so I'm not sure if the participants today know that actually you're part of the judging panel for round two. So your words of advice is definitely something that they should take. Yeah. So thank you so much for that also. Yeah. maybe we'll just wait for one more minute or okay, let me just see. Let me just recap and then we'll see if there are any more questions that will be coming in while I recap. Yeah. Okay. Let me just find my slides. Are you able to see my slides? No.
Not yet. I see a blank screen.
Okay. Maybe my slides decided not to work today. But yeah, so basically we do have a Discord channel where usually we will ask you to direct your questions there. So any questions that are related to the challenge or any questions related to NVIDIA, even you can ask on the Discord channel. Otherwise, we do have the email that we have plastered all over the website, which is the info@cdevchallenge.ai, if I'm not wrong. Yeah, so you can also ask your questions over there. If there are any questions related to NVIDIA, we will actually direct them to Dr. Deb over here. Yeah. Actually, there's one more question in the Q&A box. It says, as a beginner, how do we make a feasible website to showcase our prototype from Figma? Dr. Deb, can I ask you whether you would like to answer that question?
This feels like influencing. Okay, this is where your creativity will come in. But let me see if I can answer the question in a different way. Why does it need to be a super fancy website for a hackathon? If so, then what is your plan to scale something like this out in your real product, right? So today there are so many tools that can go from Figma to website off the bat. I'd say start with that. There are an absolute slew of models that can help you even write the skeleton code for this. Yeah. So my suggestion is to try and build that out. If your task itself is to do this, like I want to build a tool that takes in prototypes from Figma and creates a website, then that would be part of the challenge. My suggestion is to look at a variety of different model types and most importantly, break up the evaluation. Like once you build a website, what's missing, what's broken, and do you want to use human resources to fill that gap or do you want to use an agentic system? So structure your workflow accordingly. My general advice, and this I'll be careful how I say this because I don't want it to be misconstrued. Okay, if you are calling an LLM API and that is powering the intelligence part of your platform, you are technically not a generative AI developer. Right? And that's important to note. What you are is actually a generative AI UX developer. Okay, so that's really important. Then the skill set that you will need to build, the things that you will probably want to focus on if you are building a business around this, is more on the UX level, right? So essentially, that will really impact the let's say you get $1 million of funding, you're very lucky, and how do you spend that $1 million? What a lot of companies fall into the trap of is that they are actually Gen AI UX companies, but they spend their first $1 million as though they were a Gen AI developer company, right? Okay, so that is something that and there's incredible value in both. But there's no better or worse, by the way. That's not at all what I'm saying. Okay.
Yeah. Actually, they said thank you for answering their question because it's their first experience in calling an LLM in the website. So they were wondering how to have it in a website. Yeah.
Okay, this is a pretty basic question. So I think the first thing I would do for you is to actually take the free agentic LLM course, right? That will help answer some of the questions. But essentially, what you are doing whenever you say you call an LLM from a website, it's usually via API access, and that API is basically you're hitting somebody else's IP address. For something like OpenAI or a Gemini, right? They have it public. The IP address under behind OpenAI.com is actually a set of custom IP addresses that a DNS router brings you to. So for your specific use case in your website, you probably need to have that. Just link it to an IP address. That's the simple answer. But I think for you specifically, I would invest in a bit more foundational training before you start building. Yeah.
Yeah. Thank you for your advice. Okay. I think my slides are working. Yes. Okay. So let me just recap for today. If you do have any more questions at all regarding the challenge or even for NVIDIA, you can direct them to our Discord over here, which is our primary communication channel. Otherwise, you can also email us at info@cdeveloperchallenge.ai. Yeah. This one is just an extra where if you have Sea Lion related questions, you can also email caidevchallenge@aisingapore.sg. Yeah. Also, so we have other workshops and also mentor office hours that have really good people that are coming in. Just like today, we have that from NVIDIA. Thank you so much for spending your time to give us this insightful talk. So in the next 1 week, we actually have 2 mentor office hours. So tomorrow we have the business one, and on Thursday is the technical one. And then for those of you who are like you already know your cloud providers, either GCP or AWS. And if you do have questions for them, the experts for GCP and AWS will actually be having clinics. So for GCP, it's this Friday, 5th September from 9:30 to 10:30 a.m. And then for AWS clinic is next Monday, 8th September, 9 a.m. to 10 a.m. And this is actually GMT plus 8. So for those of you who are in GMT plus 7, you will just need to minus 1 hour from the times over here. But also you can just join our shared calendar here for you to keep track of the different workshops and also different events that we have for you throughout the challenge. Yep. Okay, so I believe we have overrun. I'm so sorry. But yeah, that's all from my end. Thank you again, Dr. Deb. And if there's nothing else, we'll end the session now. Yeah. Bye.